Welcome to the AECOsim Building Designer for Airports presentation. My name is Mark Enos. I'm a Senior Application Specialist with Bentley and the Building Products. We have solutions for world infrastructure and sustaining the infrastructure as well. We have solutions for buildings, bridges, roads, plants, utilities, and airports. We have project books that are basically other products that work with Building Designer. We'll be looking at those as well as enterprise solutions that help us collaborate and publish and manage all project information. Think of an airport as a tiny city, so there's going to be a lot of other tools other than the building tools that will be needed on this project. We'll be taking a look at Building Designer, quick overview. We'll be looking at Building Designer Airport Lifecycle. We'll be looking at the airport playbooks and then an airport project showcase. So you'll be seeing some models and examples of the workflow of this particular airport. It has a main terminal, it has a parking structure, a rail, admin offices. So there's a lot of other pieces and parts that ABD is used, but then there's also road, rail, bridges, utilities, and a lot more that we'll be seeing as we go through this example. Quick overview of Building Designer. It has tools for architecture, structural, mechanical, electrical, and the power of MicroStation for 2D and 3D. It's all bundled into one set, one install. It also has tools for conceptual design built in, clash detection built in, visualization, generative design, and drawings and reports. Let's take a look at AECOsim Building Designer in an airport lifecycle. Starting off with planning and conceptual design, doing some layouts, moving into the design phase, and then into construction, and then later on into operation. We'll be starting off with conceptual design, our program data, space planning, mass modeling, and solar analysis. For the design side, we'll be looking at computational design, interoperability, visualization, and publishing. When we come to construction, we'll be looking at clash detection and resolution, reporting, cost and quantities scheduling, collaboration with the field, and then punch list items. In the operations side, we have tools to be managing spaces and leasing information, assets, publishing to COBE, warranty information, and maintenance information. Starting off with planning with our conceptual design and program data. Most projects start off with some sketches, maybe over a glass of wine or two, and some sketches on a napkin, but any freeform drawings that you've done can be captured in and referenced into your project. You need to be making some line work, describing to others on the team how the project will be laid out with the main hall in the center and then the 4 concourses coming off the sides. And then we'll be having 2-story with main concourse and retail and support systems in between. An international airport has a lot of issues when it comes to deplaning international travelers who need to go through a sterile corridor system to get to immigration and customs. So that is a consideration on just how logistically that will work. Drawings we can reference into maps or aerial photographs, be working with the other engineers to be laying out the roads, existing roads and new roads, existing rail and connections to the airport from the rail, the new runway, the existing runway. So it's just a great way to be starting off on a project, communicating with the engineers from just single line drawing. The project itself has a substation, it has the new terminal, it has parking, an admin building, rail tunnels, and we'll be looking at those as well. Starting off with space program and space planning, most projects have space planning programs that you'd want to start, and we can import that directly into Building Designer. The hand-drawn sketch, an early scheme of how the main hall might look, and that was actually a JPEG that was brought in, and then the outline of the building is in line work, CAD vector line work. So we can import from Excel or text a program area. So this has the room types, the labels, the square footage or square meters, and we go from the pick list and you're placing the shapes that are that corresponding size. Then on the fly, you can change them. You could use our modified tools to be changing the square footage, but it will be displaying what was the program area versus the actual area. It's also tracking that square footage or square meters, the energy analysis information, and the space classifications. We can be putting in multiple shapes at once, so some retails coming in back to back, and we can be bringing in multiple shapes. So it's just a quick way to be importing data from a spreadsheet. And then you'll see after we get the main hall completed and put the food court in, and then we can have tools to go in with the spaces and actually start popping it up into 3D, then to be placed in doors and windows. So we have tools that we can be querying the spaces for landside and airside, or for public and non-public areas in the building. And then we'll start off with some mass modeling. We can take that shape that we started off with at the very beginning and start with our powerful solid and surface modeling tools. We can start extruding up even through reference files or XREFs, so that could be copying these floors up multiple times. And then I could be turning on an early grid from our structural engineer who was putting down some grid lines for us. And then that main hall is going to have a higher roof area on it, so we just want to mask that piece out. And then the sky lounges above the gates are for the airport lounges. And then we can be tagging on these solids to be tracking the square footage as we go back and later start doing pushing and pulling on the faces, the edges, or the vertices of these solids. So then putting it on the sky lounge, and it will put labels in as well. And then the main hall. And our solid, and you're seeing in our data group Explorer that it's tracking those floors, what the square footage is, and any classification information that we want to track. So I can go in and draw a line, a profile that'll be cutting the roof, because we know we want a curved roof, barrel roof form. We don't know what yet, but we just want to have that information tracked. Then when we go in, pointing out the square footage of the sky lounge, when I go in and grab either the face or an edge, you'll see that the square footage and the actual area of meters change those, making that modification. So you're not doing a massing model and then having to go in Excel and tracking it. It's all happening from this massing model. Once we have the massing model done, we can take advantage of AECOsim Building Design's unique ability, which is hypermodeling. And basically what that allows us to do is that we're cutting our plan sections and elevations from a model, even an early on model, and I've created with a gray background just a drawing showing the outline of those floors, but then I could be adding embellishments and labels and people and cars and where the underground rail would be going. But then with our hypermodeling, we're able to have automatically the 2D drawings and line work infused back to the 3D model, so you could be seeing exactly where that cut, all that information back in the model. Another cut is through the concourse area. We can be making that cut and start putting labels showing the two-story spaces, the sky lounges at the top, the apron level, and everyone on the project team could be seeing. It's not on some separate drawing somewhere. It can be, but it can be automatically linked to the 3D model by just clicking on those little icons on the screen. We can also geo-coordinate our models into the site model. So it's always a challenge on a project because the architectural designer and the engineers typically work in different units and different rotation than the civil people do. So we're able to geo-reference our models. We still work in the architectural models in X and Y 00 from the bottom left corner, but when we reference in the model to the site, every time we're bringing things in, we can have monument points and have a geo-referenced. So this is great that people don't have to be moving their models and their files around every time, and it also gives you the ability to import and export to Google Earth. So it's a huge time savings to be actually placing the model where it exists, even though when you're in modeling it, it might not really be there. Once we have that massing model in its proper location, we can be doing analysis of solar information. So we can do solar studies and shadows studies. And the thematic image at the bottom is showing the exposure of the sun during the day. So the blue is like only a few hours, and the red is a hot spot where there's a lot of sun. This will help determine where we need some solar screens, and then we can also be doing shadow studies. Other than the building itself, there's also parts of the airport that have considerations for solar analysis, which are the runways and having shadows on from the example of the control tower onto a runway. So that's something when early on we can be seeing if there's any problems of having that on top of the runway. Then moving to design, we'll be looking at conceptual design and design alternatives. We have a product that's in the Building Designer, Generative Components, which is a scripted-based rapid optioneering solution. It basically allows us to take the geometry from Building Designer, the columns, the walls, the doors, the windows, the beams, and drive them through a parametric script that we could be making quick changes and design iterations. So, down at the bottom, there's a relationship diagram. Then there's also a control panel that has, you can key in values of the heights or the spacing of columns. And then you could even be grabbing points in the 3D model and adjusting it as well. So on this slide, we're starting off with a 2D shape that's in a reference file. And what we can do is that we can have the line and surfaces, and we link the transactions over on the left. So you're actually putting in control points where we want to have the structure, and then it creates a line, and then it creates the columns. And then the sliders can change those expressions. So we can go in and change the base spacing of rows from 9 bays, you see in the upper right corner, to 7, and you'll see how the entire structure and the roof form modified themselves. And then changing it back to 9. We can also, and it's tracking in our data group system, the intelligent objects, the beams, the columns that are in there, scheduling it so you can do reports, how tall they are or how long they are as well. We can also be referencing in and driving a curtain wall system that is in the file as well. After we do a quick height change, so you'll see how all that adjusts. And then adding those curtain walls, you'll see that those planes are coming in that will then be all linked together. So as we're changing those parametric formulas of the roof and the structure, it's also affecting the curtain wall. Pretty much with our tools, you could be modeling anything. You're not limited by the software. We give you the tools to make your own parametric relationships. And here you're seeing a view of our massing model, our roof and structure of the main hall that we just exported in generative components, but then we're also referencing it into the site plan. You'll see the engineers are starting doing the roads. We have pads for the parking structure and also an area where the light rail is going to be, and also the pad for the admin building. And since we're referencing in the massing model, you're seeing those early section cuts in another window view that you could be turning on or off to be showing other team members when we're doing the floor to floors and start figuring out all the approaches to the airport for the bridges and the roads. This is a very priceless piece of information early on in a project. And here we've turned on, starting putting in the spaces of the different areas of the building, and we could even mirror copy anything that is repetitive between these concourse C and D, and we have tools to import from Excel. So if you want to swap out room numbers after we place the spaces or update any of the spaces, we can do that as well. So again, we're working with our Bentley tools all in one environment that we could see each other collaborating live. But there are times we are going to be working with team members that are using other tools. So we support interoperability. We support IFCs, real DWG to 2016. We support OBJ files, 3MX files, Rhino files, SketchUp. We can bring in RFA content. And we can bring in Revit models through an iModel plugin. So it would be a read-only model that we could be bringing in. So we'll be seeing here on a campus, like an airport, there's going to be multiple buildings, and people might be doing some of the other buildings in Revit or Allplan or ArchiCAD or 3D Studio Max. And we're able to bring those in with our iModel technology. We're bringing in the precision graphics and the intelligence into our environment, our AECOsim Building Designer environment. We also support Kobe. Our iModels are the way that we go to mobile in the field with our mobile devices, and we also support, we're gold partners with Adobe to create 3D PDFs. Interoperability is important when we're working in our BIM model. There's a lot of objects we might not want to create that don't need to be parametric, for example, but we can be bringing them in. So in our AECOsim Building modeling approach, we're able to use reference files like XREFs. So the building is broken up, which we'll be taking a look at later, but then you'll see the roof structure of the main hall that's referenced that was done in generative components, but Building Designer and generative components are both in the DGN file format. We can be bringing in SketchUp files for the jetways and some light fixtures. We can be bringing in from 3D Studio Max for some of the planes. We can be bringing in OBJ files for plants. We can be bringing in RFA, a Revit blur screen that we'll be taking a look at later that we could be modifying. We have an interpreter to be bringing in RFA and manufacturer content into Building Designer. We can also be bringing in WG blocks, 2D or 3D, and add intelligence to them, or bringing in 2D or 3D graphics from MicroStation and add additional data on them as well. when we're bringing in RFA information, we have a wizard that maps the RFA file to the building designer part and family. So that gives it all the symbology that it's going to be on the right level in the model, level, color, line style for the drawing and the 3D model. And it also maintains parametrics if there are parametrics in the RFA. In this example, this is a fuller screen that was brought in through the wizard and placed in Building Designer. And even when you click on it, it tells you it's an RFA file. And if we select on one of those or multiple ones with our Universal Modify tool, you'll see a preview of the solar screen. We can go in and change the size of it, and then you'll see that it's gotten smaller. Doors, windows, air handling units, anything like that, if they're not locked down to be changing certain values, you could be editing them in Building Designer. Building Designer also delivers dimensional data sets with architectural content. So we have parametric content for slabs, walls, roofs, doors, windows, curtain walls, stairs and handrails, and much more. Furniture, fixture, and equipment, and we also have Kobe templates to be going Kobe as well. And then we also support international classification systems when we're in placing the objects of either master format. There's many international classification standards, and we support most of them. When it comes to our delivered parametric structural content, we have concrete, steel, and timber that are parametric for columns and beams, foundations, slabs and decks, trusses, joists. We have 20 international countries of steel section profiles, does automatic cutback and coping, it does insulation on the beams, fire insulation. We can import and export for analysis for RAM and STAD, and then we could also import and export to CIS2, SDNF, and IFCs to go to a detailer to go to fabrication. Bentley also has an ISM model that will allow you to do the round tripping back and forth between RAM and STAD. On the delivered parametric mechanical content, we have HVAC, rectangular, round, and flat oval ductwork. They're parametric in size. They can be placing as you go with automatic fittings, insulation as well. We have many components, sizing tools, and a dicer, and the train ductulator. We can also export the cam duct, either the entire system or a highlighted route or path or individual object, as well as we can go to Vulcan by Trimble for sheet metal cutting, and then going on to more detailing for that file format as well. It creates an iModel. We have piping modeling tools that are also fully parametric, straight, flexible. We have manufacturers, catalogs we can link to and import. We have components, equipment, and vessels, and we can support sloped piping. When it comes to electrical, we have power distribution, lighting, alarm systems, telecommunications, and many more components. It does circuit design and length calculations, raceways, conduits, panels, luminaires, circuits, and schedules. And it also works with several power analysis applications and lighting analysis applications. So you can go out and do the analysis and bring it back into AECOsim Building Designer. Now, when it comes to how we break up our models, we can actually push and pull our models. We're a federated approach, so we're not locked down. It's typically not one big file. We reference it into an empty file that we call a master model, but we can have multiple people working on multiple pieces of the building by discipline or by floors. In this case, we've modeled the building by floors. So we can see that when we go in to look at our references, that there is, for the apron level, we can hover over top of the floor, and you'll see that it's like a layer cake. But if I hover over top of that wall, it's a precast panel type 1 on the ground level, the apron level. If I go up to the second floor, it's a metal panel type 1. So I could quickly swap out different reference files. So I could take that ground floor exterior wall, copy it, then modify it, then reference it back in. Because what I want to be able to do is say, hey, what will this look like? Or, report of cost and quantities if I change that to concrete block, and then I've changed my windows. So it's just a quick way that we could be, during the design phase, changing different elements of the model that updates the drawings and the reports automatically. Another method is that we can be the exterior shell of the building can be done in multiple layer modules. So think of the Bentley DGN file format like a Excel file, that there's multiple worksheets or workbooks in a file. We have the same capability that are like sub DGN files, so I can be building a library in one file that has these different modular bays. So I make one, then I copy it, then I make a modification, I could go back into my main master model and be able to swap them back out. So it's a really fast and effective way to be looking at different design alternatives. So I just made Bay 2C, and then I can go ahead and delete the window on the second floor, so I have a different configuration as I'm in doing my design studies of the exterior wall. And then I've referenced in just a portion, because this is kind of a repetitive building between the gate area and then the support areas. So I'm able to just take a part of it to be exploring the different materials. And you see I can go in and change out one for another. So I'll take that bay and go to 1A, which now has the white metal panels going on 3 floors. So it's just a very powerful and quick way to be doing design exploration. We have integrated visualization. We use the Luxology or Modo engine in Building Designer. So these are some early examples with no real materials. It's just out of the box, pushing a button. Most of our walls, doors, and windows do have materials attached to them. In the upper left, that is an image of an ambient occlusion. So there are times you want to be showing views of a model to a client without having any materials on it. So we could be turning it off, versus when we start moving along in the design process, when people start worrying about what color stone or things like that, we're really talking about the volumes of space early on. We're able to be in these snapshots. We're continuing through the model. The upper left and lower left are pretty much renderings, and the upper right with not much tweaking, just some setting on the lighting. The lower right is coming to the ground level of the rail station that's underground. So we could be rendering as we model. Up on that Sky Lounge area, we have videos that we saw in the upper right, those solar screens. This is where the club lounges and the restaurants are. So you can see during the day or in the morning. And then this is a view into the restaurant. And again, another view seeing Terminal D off in the distance, Concourse D off in the distance. And then we have some new capabilities in technology, which is the light manager. So we can go in and be tweaking the lights after we've done the solution to be adjusting it. And you'll be seeing the lights from the fixtures. And then there's some cove lighting up above in the ceiling space that you can be tweaking as well. So it's a very powerful and fast system that's all built in. You're not having to go into another program to be capturing the rendering of your building. We are gold partners with Adobe, so we have the Adobe driver, so we can be making 2D PDFs or 3D PDFs. So a 3D PDF, all you need is Adobe version 7 or above, and you take a that you publish, and once you go into this file, you can walk, zoom, rotate. If there was an animation set up in the building designer model, like this elevator, you can turn it on or off, or you could even not publish it. You could be changing the display styles from transparent to solid to illustration, shaded illustration, back and forth as you're working. We can be turning on and off models like furniture, fixtures, and equipment in a separate model versus the skin or the structure. And you can also be turning on or off levels. So we have saved views that we have in the model, but they also come through into the 3D PDF. It's just a great way to collaborate with consultants or the owner that might not want to be opening up any type of complex models in a CAD or BIM platform. All they need is Adobe Reader to be communicating. The third method we can publish is called an iModel. And what that allows us to do is take from all Bentley products, as well as we have plugins for other like Revit, modeling software, or IFCs, that we could be publishing a container that has all the geometry and the precise geometry and all the intelligence on the objects. And provenance means that it knows where it came from. So when we go from building designer, it knows if it's out of date or not. So with these iModels, these containers, we can be going to dynamic review, structural analysis, clash detection. In our other products, we can do material estimating and schedule simulating. All you do is you're in model, you can just publish it out, and you could even be doing a batch without opening the files. Moving to the construction phase, we have in tools for clash detection, both hard and soft. You could be doing clash detection within your discipline or between multiple disciplines. So it's really a good practice. You're able to clash as you go before you let other people view your models. You want to make sure what you've just done. So in this case, you'll see the walls on the second and third floor touching each other going through the slab, and that's a clash. But then once you correct it and rerun it, it will say it's been resolved. It'll also be tracking any of the objects, doors, windows, in this case, an escalator going through. We also do schedules and reports. We can export and import to Excel. We can do bill of materials. We can do quantity reports of linear length, surface area, volume, and counts. And we can also do cost estimating as well. And those models I talked about before is how we work with mobile devices and our product called Bentley Navigator. And those saved views that I was showing you in the 3D PDF are also here in our mobile device to be jumping back and forth between these different areas of interest. You can be doing clash as well in this tool, or you could be doing color-coded views based on the intelligence and searches. And we could also be doing with the iModels, the punch list and redlining. You're able to go through and have an issues forms manager. You're able to take notes in the field on your mobile devices and then push it back. Moving to operations, we have tools for leasing, space management, tracking, warranty, and maintenance, and Kobe. With our leasing tools, we're using the space tools for leasing. So you're seeing in the airport, there's a lot of tenant spaces that need to be tracked. So you could be tracking anything about the name of the store, the owner, the contact information. It's automatically doing the square footage. But you'll see that you could also be putting the date of when their lease expires. You could even be linking a copy of the lease to that space. If you're in looking around, you can use a document link to be opening up a PDF or Word or Excel document. When it comes to space and asset management, Building Designer is very powerful. It might be hard to see on the screen, but all the seating areas that are in this gate waiting area on the bottom right in the Data Group Explorer for furniture, fixtures, and equipment and spaces, so we can combine different element types or catalog types of chairs and seating areas or furniture or equipment. But what's really cool is that when you're placing objects in the model and you have a 2D or 3D space defined, it knows what space those objects are in. So when you move them to space, it'll track it and you could schedule it. So automatically you're seeing that all this seating area is in gate CO5 holding area, and the number of the room tracking the area of that room. This also works for mechanical as well. We call it spatial containment. So you're able to have, using our other tool of the item browser or the navigation pane, you can go in and be looking at different spaces and see which diffusers are in which rooms. So it could be furniture, equipment, as you're tracking it. So it is a way to be managing all this information after design and construction. The model can be used to be tracking assets and even people. You could be making a person be an employee, be an asset to be tracked in the space that they're in. We could be tracking and quickly finding the assets in the building. We have several different ways with the item browser and the Data Group Explorer. Once you highlight something on the list, you right click and it zooms right in to find it for you. So we could also be linking warranty and maintenance documents to objects. In this case, we've linked the VAV box information to the actual VAV box. So it's all that warranty and maintenance documentation is linked in the model. This example, we have a toilet room, that 3D model, that by just going in and turning on view attributes of markers, you'll see little icons of PDF, Excel, Word, or a image document, and just rotating around and hovering over top of the objects, you'll get a preview of what the document is that's linked. So in this case, it is a soap dispenser, the PDF, the cut sheet. There's a photograph of it. And then you could be looking at the paper towel dispenser, the mirror. So it could even be a movie file if it's maybe a piece of mechanical equipment that's showing you how to change the filter and things like that. So it's very powerful to have all that information linked into the model. And to just do it, all you have to do is like link from file and click on the object, and it will link that to the intelligent object. We also can export to COBie, which is going through IFCs for facilities management handover if you're going to some other FM systems, enterprise solutions. So COBie is the construction operator's information exchange. If you don't know what that is, that's when you're going from design, build into operations. When you're going from build into operations, that's where you want to be taking all that product data, the as-built information, and start pushing tag data, serial numbers, warranties, information into the model. When we put COBie from Building Designer, we have three options. We can go to the standard COBie Excel spreadsheet, we can go to the standard IFC model, or we can go to an IFC I model. When you export out, you can do all of them, one of them at a time. This is one of the floors in the airport, and you're seeing it's just going to export IFC, and we choose Facilities Management Handover, selecting all the options to create the spreadsheet, the iModel, and the IFC file. Building designer uses the floor manager to be doing the spatial containment when it's going out into COBie. And that's the floor manager that as we're working in 3D, we're able to lock on the different levels in the building and create drawings from, but it's also used for COBie export. This is a view of an IFC model, an export from the COBie. So you're seeing not everything came through, only elements that you want to be tracking operations and maintenance on. So there's standard COBie templates that we have that you could turn on anytime during the design process, either start with the COBie data set or add it near the end, and it's just more fields of data about warranty information, install dates, tag information, and all that data. And you're seeing that when I highlight on the Explorer on the left of that television screen, also in the Excel spreadsheet. And in the upper right, that television screen is highlighted. It zooms in to show you where that is. This is a full view of the COBie worksheet with for space, zone, type, component, system and assembly, etc. One of the huge benefits of Building Designer that a lot of people take advantage, kind of forget, is our ability to handle large and complex models. So here's one of the master models of Building Designer of the airport, and I'm rotating this around and going through save views, but you're just seeing I'm in a display mode of illustration that you're able to quickly navigate through the model. And depending on how you have your model set up, if you're doing exterior elevations, you might want to be turning off the interior models and just leaving the exterior shell. That's typically how we do it. But it is a very fast, high-performing system of having these federated models that we're able to quickly navigate through. And then just zooming in on the entrance of looking at how the design has developed from that generative components, roof, structure, and curtain wall system. Now we'll take a look at the Bentley playbook. Again, this is looking at Bentley's other complementary solutions that work with Building Designer. So the one I want to really focus on is ProjectWise. It's more than just a collaboration tool. It basically manages the workspace, all the data behind the intelligence of Building Designer. So ProjectWise allows you to manage all of your standards, point clouds, context capture, which intelligent, photographs, map data, specifications, BIM models, CAD drawings, facility data, asset data, images, renderings, and maintenance information. So all those links that I was showing you on the toilet room of the cut sheets, ProjectWise manages those links as well. And we support MicroStation, AutoCAD, ABD, or AECOsim Building Designer, and Revit files in ProjectWise as well. So it's an email. Any project information is can be captured in ProjectWise. ProjectWise has some other huge benefits. Single data repository. It has secure access from different groups or individuals. Application integration means it would only let you open up a file with a certain application or version of an application. So that means you could tell a folder to open up with Revit, 2012, and then Building Designer select Series 6. You're able to have multiple versions, and you won't be having people opening up files with the wrong version of software. It also does document coding, and then with the document coding, it'll also do attributes that can automatically be populated into title block. It's workflow management for state and workflow, and it can also send the team notifications when new files are added to the project, or if models or drawings or any project information goes from one state, from like a design state to a review state to a approved state, you can receive notifications. It also does read exchange. A great tool is the dependency viewer. That is those linked models or drawings that I was showing you before of a federated database. These are XREFs. So there is a database tracking every file. So if you move or rename a XREF or a reference file, it doesn't break the link because the database is tracking where that is. And this dependency viewer is actually showing you what files are referenced into which ones. So it's just a great way if you're new on a project, you can just without opening up files, you just click on it and it'll show you what files are referenced in. And it'll even show you highlight a file and say who is referencing me before that you want to maybe delete a file. It will let you know, are you sure you want to delete this file? Someone else is referencing it. So it's really a great control system on file management. We also have spatial data management. So here on our airport, we can have project-wise with the geospatial that when you hover over top of different parts of the airport, the files are geolocated. So when we're clicking over the runway, you'll see all those files that have to do with the runway. It's a different way of working, that it's not going from a file list, but it's actually going from georeferencing. We have powerful tools that you could save personal and global. We have a built-in viewer to turn off levels on and off before references before you copy it out. We have web access. Looking at our other playbooks, more of playbooks, work with BD, AECOsim Building Designer. We have Site Ops that does grading and stormwater, and cuts and fills. It also does quick optioneering of parking layouts, so you can see where the parking garage is versus where the surface parking is, and it automatically puts all the parking spaces, and you can adjust and move, and it's very parametric and fluid and comes up with many different options quickly. It's a wonderful tool. We also have AECOsim Energy Simulator that, going from Building Designer, we create an analytical space model, an ASM, that gets brought into Energy Simulator that can then be looking at different reports of temperatures around the world. So we use the DOE's Energy Plus as the industry standard simulation engine. It does detailed energy analysis using out-of-the-box HVAC systems, and it can be edited, and it has 7,000 worldwide locations available with weather data. And you can just see properties on one side of the building and all the spaces on the left of that main terminal of the airport. AECOsim also works with Descartes, context capture, and our point tools, so we're able to bring in all this information and be having hybrid models with intelligent BIM, with as-built from aerial surveys and other type of scanning, and it can do color model exploration. It even does clash detection and conflict resolution. Sim and Power Rebar and Pro Concrete was used on the rail station that's underground. This is the completed rail station, but you'll see that it's part that's around that cool curve shape, but below ground is the station itself, and that was all using Power Rebar and Pro Concrete. AECOsim Building Designer also works with Bentley Substation for design of gas and electrical substations. Building Designer is the wrapper of the building, but we can also see through iModels all the data off the objects. We also sim with our bridge solutions. We have several. One of them that was used on this particular project was RM Bridge, which was the approach to the airport terminal and you're seeing that there's a partial model that was clipped of the entry of where the bridges are going up to. AECOsim and road, all the roads on the site were done in open road, and we can reference and read those roads as well, and they have visualization and actually have traffic and vehicular animations that are possible. Building Designer also works with power rail and track and power rail overhead line for the train, and it also has headline covered trench as well. And then LumenRT is a fairly new addition to our portfolio of products. It really is a tool that lets you paint. So you export from your BIM models or any multiple types of models, and you're able to paint landscapes, trees, animate people and cars. And so this is just a longer version of the airport model taken into a LumenRT. AECOsim Building Designer uses a part and family system for the rendering. So when we place those precast walls or the metal panel walls, that's what we see in Building Designer. That goes through into LumenRT. So all the building components go through, and this is just a tool for you to be changing the weather conditions, the time of year, to be sculpting hills and mountains. If you're seeing off in the above, there's some little mounds of dirt that was all created in LumenRT. And then we're passing by the parking garage, looking at the rail station with people out hovering around. And that's the entry to the main terminal of the airport. And again, it's a very powerful tool that can handle these large and complex models. And then coming up from the end of Concourse A and looking at the whole project. Then we have a little airport showcase that's available online that we could send you the link if you contact us for different Bentley projects that were done for airports using different tools.